All right, example 7 from half angle section. Let's see if my pen is calibrated. Nope. A little bit of everything going sideways this morning. What about him? Oh. And so you need to pray to your God to help you? Oh, I thought you said, oh my God. I thought you were like starting a prayer. The Catholics know a prayer starting with oh my God. It's called the Act of Contrition. It's for people who don't C-A-R-E, right? Any Catholics in here? Whoop, whoop, there we go, right? Oh my God. I think it's changed now. They changed it. I go to Catholic Mass now and I say all the old stuff and the new people say the new stuff and I call myself out like, you haven't been in a while. Oh my God, I am heartily sorry for having offended thee, and I detest all my sins because of your just punishment. But most of all because they offend you, my God, who art all good and deserving of all my love. I firmly resolve with the help of your grace to sin no more and to avoid the near occasion of man. O clement, O loving, O sweet Virgin Jesus, pray for us, O Holy Mother of God, that we may be made worthy of the promises of Christ. Yeah, I was just, when you grow up I grew up in Catholic school. I went to parochial school. And like every day they make you learn a new prayer. So I got a lot of prayers memorized. That was like our curriculum. And that's one of them. And so it just sticks. It's in long-term memory. So that was me basically just telling, I guess, God that I was sorry. But anyway, Caitlin, you brought it up. I did not. All right, here we go. Example 7. And by the way, that was all recorded, by the way. So if you want to hear that prayer again, it's called the Act of Contrition. Danielle, do you know that one? The Act of Contrition? I don't know that one. You don't know that one. Do you know the Hail Holy Queen? No. Do you know the prayer before the crucifix? No. But you do know the Our Father and the Hail Mary. Yeah. Okay, that's the staple of everyone. Yeah, Lutherans same way, except it's the comma Johanneum, faith alone. Catholics require faith and good works, but clever Luther is just like nope, faith alone. Clever Luther. Find tangent of x halves if sine of x equals -2/5 and x is between pi and 3 pi halves. Okay, so sweet. So first thing we're going to do is we're going to say, okay, if I can identify where x lives and I can find all 3 trig values for x, if I can then express an angle that's half as big in terms of x, the larger angle, I can find its exact value. So it starts off as a 2's clues problem, but it's actually really easy because I'm telling you that x lives between pi, which is here, and 3 pi halves. So that puts it indubitably in which quadrant? Quadrant 3. So if we drop a perp vertically, which is pretty hard to do, we now label the sides. We're given sine is -2/5. Remember, sine is y over r, so it has to be a -2 and a +5. All right, and now by the Pythagorean Theorem, x is equal to plus or minus the square root of 5 squared, which is 25, minus -2 squared, which is +4. That's plus or minus the square root of 21. Do we want the positive or the negative here? Negative, good. That's something right there that some students may overlook. But we are in quadrant 3 where both x and y are negative. Does square root of 21 simplify to anything? No, it doesn't. Okay, so we have all 3 sides. So now I can figure out what the tangent of an angle that's half as big is if I could express it in terms of sine or cosine. So tangent of x halves, remember, is plus or minus the square root of 1 minus cosine of x over 1 plus cosine of x. All right, so now I have to determine if it's going to be plus or minus. And here's how we do that. It's real easy. If you take x has to be between pi and 3 pi halves, just take half of everything. That means that x halves, the half angle, is going to have to live between pi halves and what's half of 3 pi halves? 3 pi fourths, yeah. So that's real easy to figure out where the half angle lives. So what quadrant is that if I'm between pi halves, which is here, and 3 pi fourths, which is here? It's somewhere in there, right? I not only get the half angle down to a quadrant, I get it down to a half quadrant. So I know it has to live in quadrant 2. The half angle lives in quadrant 2. Okay? And now in quadrant 2, is tangent positive or negative? It's negative, right? So I'm going to go with a negative now. Remember, we have to pick that sign. The square root of 1 minus. Now all I got to do is come over here to x and pull the cosine ratio off. What's the cosine ratio? Well, it's x over r, which is negative square root of 21 over 5, all over 1 plus negative square root of 21 over 5. Okay, everyone will see what I did there? I found the sign by just figuring out where x lived, and then I divided the two values that define the quadrant, and that put me in quadrant 2, the upper part of quadrant 2, so I know tangent's negative. And then I just pulled the cosine ratio off of the triangle that I already drew. And you do have to be very, very careful with signs, don't you? Very careful with SIGN signs as well as, I guess, SINE signs. So in the top, that becomes actually 1 plus square root of 21 fifths, and at the bottom becomes 1 minus the square root of 21 fifths. So notice the signs do in fact change. And now we get to do our fun part, right? Let's go ahead and multiply under the radical by 5 over 5 if you want to do that, or you can get a common denominator. This works a little bit more quickly, I think. And if I distribute that 5 to both terms, under the radical, I get 5 plus the square root of 21 all over 5 minus the square root of 21. How'd I get the 5? That's the cosine ratio. That's cosine of x, right? That's why we drew this triangle. And then, yeah, I come back up. This is our angle x, and the cosine is x over r. So that's how I got that number. All right. So no, that's no fun. That's no fun. That's no fine. That no fine. No, you must be sorry. That no fine. You asked such a silly question. No, that's no problem. I was going to say that is fine. That's no problem. And it just came out as that no fine. All right. So now the fun begins, right? We're going to keep our negative, but I'm going to give a square root to the top. And then I'm going to give a square root to the bottom. There you go. And this kind of will start looking like what we did yesterday with tangent of pi 16ths. We got rid of our fraction first, which is generally easier. And now we have to start working on rationalizing. So if I multiply by the radical, 5 minus the square root of 21, over 5 minus the square root of 21. And the reason I do that is there's no conjugate yet. The outer later is just one radical. So in the bottom, I get radical times radical is radicand. So that's 5 minus square root of 21. Well, I don't need the conjugate yet. That's the point I was trying to make here, because I just have the square root of blob. And so I multiply by the square root of blob. So as we said yesterday, if it's just 1 over the square root of a, we just multiply by the square root of a over the square root of a. If I have like a plus 1 outside the radical, that's when I would need the conjugate. Okay? So when it's that first iteration that you're going to see, you just have a single radical down there, you just multiply by the same radical over the same radical. Okay? Now notice I'm keeping the negative in the top, just easier. And now I can say that's the square root of, I can multiply these two fellas. I'll highlight them in orange. I can multiply those two fellas under the same radical. And those are going to be conjugates of each other, right? So if you want, instead of writing them side by side under the radical as factors, you could go ahead and distribute. 5 times 5 is 25. The inner and outer cancel. And you're going to be left with minus 21. So that cleans up rather nicely. Okay, so now I need to start a new column. I don't want to impede on that other problem there. So the top is now the square root of 25 minus 21. Hey, that's 4. And the bottom is 5 minus the square root of 21. What's another name for the square root of 4? 2. So the top is really negative 2. So if you just want to, if you can do that in your head, that's good. Okay, now everybody look at the denominator. I don't have a single radical anymore, do I? I have two terms, one of which is a radical. So now to rationalize that, I have to multiply by what? The conjugate. Now because there's two terms, I multiply by the conjugate. All right, and I always do the denominator first, bless you, because that's our goal. We're trying to get rid of radicals. So I want to make sure that happens. 5 times 5 is 25. Inner and outer cancel, and we're left with minus 21. And in the top, if you distribute, I'll go ahead and distribute a negative 2. I get negative 10 minus 2 square root of 21. Or maybe I shouldn't have distributed. Oh well, I already did it. What's the bottom? It's going to be 4. So I get negative 10 minus 2 square root of 21 over 4. And now if you want, you could do the what we did the other day where you just put both over the denominator and simplify. So there's a common factor of 2 that'll divide out. So we get negative 5 halves, and that becomes minus 1 half square root of 21. Or if you want, you can write it as minus 5 halves minus the square root of 21 halves. So that's a pretty, I mean, that's kind of an ugly number, but it is what it is. That's the answer. Wow. Okay, so these half angles, as you could probably appreciate, they require a little bit of radical algebra, right? A little bit of radical algebra. But the more you practice, the easier it gets because the method is pretty much the same every time. You're just using slightly different numbers. Now, is there a way to check our answers? There's a lot that can go wrong here, right? Any one of these steps with the negative sign, it can derail you, right? And that's why these problems are so good, because they do require you to be meticulous. Let's see if we can check our work, okay? I'm going to do it in degrees just because it's a little bit easier for us to appreciate degrees. Just let the smart view go. So while it's doing that, let's review. I drew my triangle based on the clue. In the right quadrant, I found the third side by the Pythagorean Theorem with the correct sign. Once I have all 3 sides, I have all 6 trig functions for x. I then use the half angle identity to express the half angle of x in terms of the single angle x. I then figured out where the half angle lives by dividing the endpoints for the quadrants where x lived, and I got this quarter quadrant. And in that quadrant, tangent was negative. Then all I did is I pulled the cosine ratio off of my triangle right here with careful parentheses, and then the process begins. Then I get rid of the complex fraction, and then I start rationalizing it. Okay, inch by inch, it's a cinch. Now, here's a way that we could check. I'm going to go to degree mode, which I don't do often, but here we are, degree mode. Let's go ahead and actually find x. To find x, remember, I just need one trig function. So let's take the inverse sine of negative 2/5. Inverse sine, that second sine of negative 2/5. That was the given ratio, so that should be safe. Now, before I hit enter, what kind of angle is that going to give me based on the PVR of arc sine? A negative acute angle, right, in quadrant 4? Good. There it is. We don't want that angle, right? That's the reference angle. So that gives us an angle down in here. So if I can find the reference angle, which is easy, I just multiply that by -1, then my angle x is just going to be 180 plus that. Would you agree? Okay, so let's go. And this is all stuff we've done before. So let me multiply by that -1. So there's my reference angle. And now if I add that to 180, that puts me into quadrant 3. And I'm going to store that one. Let's store that as alpha A. All right, now let's verify real quickly. Sine of that should be negative 2/5. Sine of alpha A that I stored should be 2/5. Well, that's not right, is it? Oh man. Am I in the right mode still? Mode? Oh, that didn't look right. That certainly didn't look right. That angle was too small. Didn't y'all see me come over here to degrees? Maybe I didn't hit enter. I didn't hit enter. Okay, good thing we check our work, right? Now it's highlighted. Now it should work. Let's do it all over again. Okay, in case you missed it the first time. Inverse sine of negative 2/5. Now we should get a negative acute angle, but it should be a little larger than it was, right? Negative 23 degrees. Okay, más mejor que bueno, we say. More better than good. Times -1. There's your reference angle. Now we add 180 to that, and that puts us into quadrant 3. Okay, let's store that one as alpha A. Okay, cool. Now when I take the sine of that, I should get negative 2/5. This is how we caught our mistake earlier, so get in the habit of checking your work. That is negative 2/5. Okay, so now we're good. So let's do this. we want the tangent of an angle that's half that big, right? So now let's type in tangent of A divided by 2. And we're going to get an answer of that. Woof! Wasn't that a great answer? Well, now let's come back over here and type in our radical answer that we came up with. It should be the same, right? Negative 5 halves is negative 2.5 minus the square root of 21, minus the square root of 21. Here we go. Divided by 2. Divided by 2. Come on. What do you say? Give a guy a break on a Wednesday? I'm scared. But y'all were my witness, right? Y'all worked it along with me? It should be the same. If it's not the same, who's broken? Math or us? Oh, yeah. Okay. Here. I'm going to have Tristan do it. Tristan, go ahead and click. It's already on enter. Just click the left mouse. I'm so nervous. Ah! Tristan saved the day. He has the golden touch. All right. There it is. Sweet. All right. We did a great job. We did a great job today, gang. Yeah, for one problem. Okay? All the ones that matter. Okay? Well, I mean, there's other people that matter, but maybe, yeah. Everyone in here matters. That's what I meant to say. Yeah, there are other people that do matter. You're right. I guess we'll finish tomorrow, okay? We kind of had a couple of hiccups getting started here. If you don't know your identities, yeah, learn them, okay? We're going to have another quick 10 click